Okay, today we will start 9.2. However, there's one part in our textbook is missing. As you can read from the notes I write here, that this 9.2 is on confidence interval for mu with sigma unknown. And in the previous edition, we are currently using the 5th edition, but in the 3rd edition, they still have it. They still have it. In the 4th edition, they get rid of that already. That is the section about confidence interval for mu with sigma known, which provide us a foundation on how to construct confidence interval in general. And even though, according to the author, that this model, confidence interval for mu with sigma known is not realistic. It is still widely used in practice, and therefore I still teach you. Okay, so I will start with 9.2 intro with confidence interval for population mu with population standard deviation known. Okay, now here's the template. When you do confidence interval problem in my test, you need to use this procedure exactly like this. Okay, the template is first we will need to do best point estimate. The best point estimate for mu hat is equal to the sample mean. Now, don't worry, I will explain this later on. Okay, and then the second part of that is critical value. Well, from confidence level that is provided in the question, we will get the critical value, which is Z critical. Now, this is something we learned last Thursday. Now, the second step, so step 1, there are 2 parts, best point estimate, critical value. Step 2, margin of error. Denoted by E. No parenthesis, no X. That's expectation. So capital E without anything else refers to error. Margin of error is equal to the critical value times population standard deviation over square root of the sample size. In step 3, declaration. This one you need to explicitly set it out. Confidence interval for mu is given by, x bar minus E less than mu less than x bar plus margin of error. Okay, that's the template, and that's basically it. Okay, that's basically it. What we are going to do is in 9.2 and 9.1 later on, we will apply this template. And of course, we still have a little subtopic later on, but we will focus on this first, okay? Yeah. Now, let's do an example to explain what we had, the template there. For example, we have a sample of let's say 40 people, okay, and then the average height of that 40 people, let's say is what is good, 61 inches. While it is known from the past, the standard deviation, population standard deviation of adults' height will be 2.5 inches. Now, suppose then we want to know what is the 95% confidence interval for population standard deviation. So let's say we have 40 students, 40 adult students from West LA College, okay, and the sample mean of their height, the average of these 40 students' height is 61 inches. Then can we predict that where or what interval will the population mean of all students at West LA College height will be with 95% confidence that the mean will be in that interval. Okay, now here's the thing, step one. I tried to explain why the procedure looks like this. Step one, best point estimate. The best point estimate, X bar equals to 61 inches. Now, what is best point estimate? Now, the thing is, if we need to pick only one number, if we need to estimate the population mean, the overall average height of West LA College students, and we can only pick one number. By picking one number, then what number will that be? Now that number is called best point estimate. So suppose we know that the mu can be anywhere from 0 to infinity. Of course, the average height will be infinity. Okay, if I can pick only one number from this 0 to infinity, what number will that be? Then according to our central limit theorem, that number will be 61. Okay, which is the X bar. Okay, now keep in mind that this relies on central limit theorem. Relies on central limit theorem, which implies first, either the population is known to be normal, in this case, the population height is normally distributed or approximately normally distributed, or on the other hand, the sample size is at least 30, which is the case what we have here. Okay, now, so if the population is not known to be normal or the sample size is less than 30, we cannot use this model. Okay, we cannot. Well, it's possible, it is possible, but the reliability or the result will be questionable. Okay, unless we know more, for example, that this data seems to be symmetric, for example, okay, or seems to be approximately normal, then yeah, okay. But if I can pick only one number, what number will that be? Then it will be 61. Now, okay, now then second, how about the critical value? Now, they tell us that the confidence level is 95%. Now, from that 95%, we will construct what we did last time, a normal distribution, okay, with 95% area in the middle. Now the critical value we are looking for is located here. Okay, so this is 1A, this is step 1B. Okay, now then what will the C score such that the area to the left is 2.5% plus 95%. That's 97.5%. Okay, we need to look for that critical value. So the C score is inverse norm 0.97501. I believe it will give us 1.95996. You can use your calculator. Yeah, you can use your calculator. Okay, now we use C score here. We use C score here. We use C score here because the population standard deviation is known. Okay, later on, if we don't know the population standard deviation, then we need to use another distribution that is resembling very closely normal distribution, but it's not. Okay, but this is the foundation though. This is the foundation. Okay, and then step two, then we look for the margin of error. Now, basically, what is this margin of error? What is this margin of error? Margin of error basically doing the following in step 2. Okay. Now, if we choose, we already decided what is our X bar. Now, then we will use the critical number we have in number 1A, 1B to create an interval. Okay, so this will be plus margin of error to the right plus margin of error to the left. Okay, so our final confidence interval will be X bar plus E is the upper fence and X bar minus E in the lower fence, such that we create a new normal distribution, not standard, non-standard normal distribution with quote-unquote 95% probability that the mu will be in this interval. Okay. Now, because of the nature of normal distribution, the further it is from the mean, the less likely for that to happen. Now, we try to benefit from there. Okay. So, is it possible, Thomas, that the population mean of West LA College students' height is less than 50 inches. It's possible, but the probability is so small that I will not believe it. Okay, I will not believe it. Okay, it's not that it's impossible. Actually, even when you say the average height of West LA College students is 1 inch only, that's possible, you know. But the probability for that to happen is so small such that I will not even bet on that. Okay, I will say just that no, that's nonsense. Okay, now then the thing is, how do we know how far to the right and to the left from X bar should we get, which we call margin of error. Now that margin of error is given by the critical value 1.95996, and we get this 1.95996 from the confidence level, okay, times the population standard deviation 2.5 over square root of n, in this case is 40. Okay, now then we use our calculator. 1.95996 times 2.5 divided by square root of 40. That will be 0.77474. Now then, step 3, let me move a little bit to the left. Before you start your confidence interval, you need to do declaration. You have to do declaration. Okay, for your homework, that's half point. For your test, that will be 1 point there. Okay, you need to do your declaration. Let's see, I have a chat coming in. How come 0, 1 used in the inverse norm? Because this is standard normal distribution. The C score here, that's standard normal distribution. Now, because it is standard normal, then the mean and standard deviation for that standard normal distribution is 0 and 1 respectively. Okay, then coming back here, then we do declaration. I will declare that 95% confidence interval for mu is 61 minus margin of error 0.77474 less than mu less than 61 plus 0.77474, which will be 60.22526 less than mu less than 61.77474. Okay, now I already walked through the procedure once. We'll do more, of course. We'll do more, and but you will see the emphasis will be you actually can follow this template. Okay, I need you to be really good with this. I need you to be really good with this, because the next 2 topics, confidence interval for mu with sigma unknown and confidence interval for P, population proportion, actually relies heavily on this template. Okay, relies heavily on this template. Now, of course, at the end of this summer, you will have the department final. Okay, and the department final will ask you this question, that question, but they also have the written part in which that you need to show the work. And when you show the work, basically the question they ask you has these ingredients here, step 1, 2, 3 ingredients. Okay, yeah. Again, the department final is written by people who, as far as I know, they may have experience in practicing statistics, but at the same time, they try to adjust with the textbook, because most instructors, they don't have that experience. Okay, so they try to adjust with those instructors who, when they teach, they don't teach with this template. But in my class, for your quiz, for your test, you need to use this. For your final, depends on the direction. Sometimes they just ask you, they don't ask you to construct a confidence interval. They ask you, for example, find the margin of error, find the critical value, find best point estimate, like that. Okay, so you basically answer those parts. But to construct confidence interval, you need these ingredients here, these 3 steps, where the first step consists of 2 small parts. Okay, now let's do some problem. I will get our problem from another textbook. Give me a second. Yeah, that's the missing part. That's the thing. I will try to make it on the simple side. Give me a second. Let's see this one here. Yeah, I get this from other textbook, actually the older textbook. Speeds of driver ticketed in 55 miles per hour zone with 95% confidence level and then the sample size is 90. So they don't, so once the sample size more than 30, then we don't need the population, the underlying population to be normally distributed anymore, because that the sampling distribution will be normally distributed. Okay, now this is one of the sample. Here, the sigma is known to be 3.4 miles per hour. Okay, now what we need to do is to construct, in this case, 95% confidence interval for the average speed of drivers ticketed in that speed zone. Okay, so step one, best point estimate. You can shorten that by BPE. Best point estimate will be X bar equals to 66.2. Now, critical value is Z critical equals to, let's do this little sketch on the right hand side here. I need, we know that X bar will be normally distributed with 95% area in the middle. The remaining 5% is being shared by both tails. So each of them will have 2.5%. Now the critical value we are looking for is located here. Now to find that, we need to find that critical value such that the area to the left is 2.5% plus 95%. Okay, which will be 97.5%. Now then, what will the critical value be? What is the C-score? It will be inverse norm 0.97501. Okay. Actually, if you use your calculator, and you just type the notation, you know, let me show you my calculator here. My calculator TI-84, I believe just like yours, requires us to put in the mean and the standard deviation for that distribution. So like second distribution and then inverse norm. Okay. Now notice that it requires us to put in the mu and the sigma, right? Okay. Remember, we use C critical, right? Now that Z refers to standard normal. Don't forget that. Don't forget that. That's very, very important though. That C is standard normal. Okay. Every time you see C, that's standard normal. And do not use C if it is not standard normal. Okay. Now the thing is, the actual calculator I have at hand right now is TI-83. Is TI-83, such that for me to type it, if you have TI-83, for example, let me go back. Then you can just type inverse norms 0.975, and you can just omit these two. Basically, our calculator, if you just type it as is without using 0 and 1 as the second and third parameter, then our calculator by default will see that as standard normal. Okay, yeah, but that's for older calculator. The newer one, TI-84, requires you to put in that 0.1. Now then, when you put that in, you will get 1.95996. And then step 2, the margin of error will be that critical number, critical value, multiplied by population standard deviation 3.4 over square root of 90. Then you use your calculator to compute that. 1.95996 times 3.4 over square root of 90. I get 0.7024 3. Then finally, step 3, declaration, 95% confidence interval for mu. Yes, you can shorten that by CI for confidence interval. That's actually a common practice. Is equal to is equal to best point estimate minus margin of error less than mu less than 66.2 plus 7. I mean 0.70243. Let me check here. So unless otherwise stated, we assume standard normal this standard normal input for it's actually not otherwise stated. When we deal with critical value for standard normal, the word standard normal means the mean and the standard deviation is 0 and 1 respectively. Okay, now here the critical value, we will use z-score. We'll use z-score. Now once we know that we use, so the key is you need to know when to use z-score. Okay, the critical value from standard normal distribution. Okay, now, but once we know it comes from standard normal distribution, then we use the mean and standard deviation must be 0 and 1 respectively. Okay. Now then from here I go on, I subtract this, it will be 65.49757 less than mu less than 66.90243. That's the answer. Now the answer, the final answer, of course, the one I underlined, but what you need to show me, in your test are all these 3 steps. Okay, these are things you need to show. Now, couple notes to mention. Maybe I use blue color notes. First, in quote-unquote non-statistic setting, the confidence interval usually written as x bar plus minus e. I think I should say in, not s, in, written in x bar plus minus e form. So for the example what we have next door, instead of writing it in that kind of interval, they would write it this way, 66.2 plus minus 0.70243. Okay, now if you see this notation, it means the mean is 66.2 and the margin of error is this 0.70243. Okay, but that's in non-statistic setting. Now, sometimes when you read the newspaper, right? Okay, or non-statistic paper, they write it that way. Okay. Now, of course, because they write it for lay people, we say, like people without a lot of statistic background. Then once in a while, this notation also being written in statistic paper. But usually they write it this way when it comes to the conclusion. Okay, that way they say, oh, you know what, the sample mean is 66.2, and then from our computation, the margin of error is this. Okay, that's one. Second, this interval is to estimate the mean, the population mean. this is not to estimate at what speed. It's about speed, right? Okay, it's about speed. It does not estimate that at what speed you will get ticketed. No, no, no. So this is just the average, the overall average of the speed of drivers ticketed in that speed zone. Okay, so it is possible. Somebody with 50 miles per hour actually get ticketed for other reasons, right? Okay, and it is possible somebody driving 70 miles per hour not getting ticket. It's possible. Okay, but if we take the average, overall, we try to find the overall average, then the average will be in this small interval here. Okay, so in practice, finding the average of the speed for driver ticketed in that 55 speed zone give us this interval. It's not helpful though. It's not helpful because that's the average, but the police, you may get one police actually stop you in much lower speed, and another police may actually just let you go when you drive 70. Now that's usually the case if they have other thing that they need to attend to, more important one. Okay, but I believe like if you are in downtown LA where the speed limit is 55, they actually already give you a sign to slow down if you have 60 miles per hour, if you drive 60 miles per hour. Yeah. Okay, but on the other hand, don't you think it's quite generous that in that 55 miles per hour zone, the average ticket actually being written in this interval, right? Which means there are some people driving at 57, at 60, actually not getting ticket. Yeah, if you think about it, right? If you think about it. Okay. Now, of course, I do not advocate for you driving at higher speed, right? But in reality, most people, including me too, actually driving more than 55 on a 55 miles per hour zone, which is not a good example from me though, okay? Not a good example from me. I'm telling you, in class, in this class, I know pretty much everything of what I need to teach, but outside of class, I'm just the same to you. You know, I'm just another guy who at times not really paying attention to speed limit. I mean, most of the time I kind of care about 65, but when the speed limit changed to 55, I may not be aware of that until somebody point out to me, like the one in downtown area, like intersection of 10, 65, around that area, right? Yeah, the speed limit there is 55, not 65. Okay, so if you have a police actually stop you at 60 there, don't blame them for bothering you because you're actually speeding by the law. Okay, now I would like them to change that 55 become 65, but you know, a lot of trucks there, so I don't blame them to put that too. Okay, now that's for this one example here. I will do one more. This one is from yeah, let's do a couple more because they're interesting stuff here. Give me a second. About gambling. The amount lost by gambler who took a bus to Atlantic City Casino. Okay, and we want to construct 99% confidence interval. The sample size is 40, and they lost by approximately 189, with standard deviation known to be 87. Okay, now we want to find the confidence interval. We want to find the confidence interval on average, how much they lost. Now, Even though this seems to be on gambling situation, I want you to later on see this from business point of view. If you are, for example, the marketing manager of this casino, then will you provide the bus, for example, right? Yeah, suppose the casino is like around 20 miles from the area, 20 miles from the area where the bus will pick up the passengers. Who will be gambler? Okay, just imagine this. Okay, so you are a manager, and then the question is, will I provide the bus? Okay, let's say the cost for the bus to go to pick them up, bring them to casino, and send them back to that initial point. So from the city here, go to casino. Actually, that's a 4 trip, not only 2 trip, because the bus will start from casino, go to the city, pick them up, right? And then bring them to casino. Later on, after let's say 6 hours, then they need to board the bus again, bring them back to that place, and then go back to the casino. So that's actually 4 trips, right? Now, let's say one trip cost the casino $100, which I don't think is an overestimate, but multiplied by 4, that's $400. Let's say it's $400 cost to get these people, okay? And assume that each time they board the bus, just a small assumption that we will get at least 20 gamblers, at least 20 gamblers. Now, so if on average they lost 189, okay, if on average they lost 189, then the casino will make on average 20 times $189. That's 2,000 something. Now look at the cost and how much the casino will make from there. Will that be a good business? And if you notice, we actually have those kind of buses in Monterey Park, not in West LA College, but nearby East LA College. We have some buses going to Pachanga, going to Pala, going to San Manuel Casino. Okay, and in fact, not only they provide the free bus for you to go there, for each passenger, they even give you, let's say, $20 to spend. But you can only spend it on the gambling table. You cannot spend it for food. No, only on gambling table. Now, even with, let's say, 40 people times 20, that's $800, right? Even if you have 40 people, okay? 40 people going there and they give you, so assume the following, like you have 20 couples going there, right? 20 couples, only the spouse will gamble. The other person in that pair will not gamble, okay? They just go around, okay? But they get the $20, okay? So $20 times 40 people, that will be $800. So the casino will spend, give them basically spend $1,200 with nearly guaranteed income of $2,000 at least. Will that be a good business? Okay, so then the manager, in this case, you wants to see, well, that's the best point estimate. This is the best point estimate. But we have standard deviation, so it can be more than this number, can be less than that. Right? Maybe more, maybe less. Okay, we don't know what's the mu precisely, right? And actually, in this case, we don't need to find out. We can just estimating it. Now, the thing is, our manager wants to be 99% sure, 99% sure that the mu will be in that interval. Now, you will see that the larger the confidence level, the bigger the interval. Okay, let's do some logic here. Okay, if I want 95% sure, 95% certainty that the mu is in this interval compared to 99%, the 99% should be larger. Okay, that's just a little common sense. Imagine if you play soccer, right? I mean football, soccer. Okay, like I'm Indonesian, so when I say football, it refers to soccer. Now then, if Thomas is here, right, and I try to kick the ball, the goal is this big and this big. Then which goal I would have more confidence in scoring? Yeah, of course, the larger one, right? The bigger the goal, the more confidence I will kick the ball in, without any keeper. Okay, without any keeper. Yeah, you know, even if you're a professional one, so without keeper, they still kick it off, right? But the larger the confidence the larger the interval, the more likely you kick that in. Now that's the reason that the larger the confidence interval, the larger the confidence interval, the higher the confidence level. Now, I also let me mention this at the same time. The smaller the larger the sample size, the larger the sample size, the smaller the margin of error, and consequently, the smaller the confidence interval. Okay, so if you want to increase the confidence level, at the same time, you want to have a small confidence interval, then what you can do is you enlarge your sample size. The larger your sample size, the smaller the confidence interval. Okay, now if your confidence level, you want to increase your confidence level but at the same time, you want to keep the confidence interval small, a more focused target, then you need to increase your sample size. Okay, now then let's work this out. Let's work this out. Even though I myself gamble until I get married, right? Even after I get married, I still secretly going to casino. Still secretly going to casino. Not a good example. Okay, no. That's not what you're supposed to do. The more you know gambling, the more you know that unless you are the dealer, don't gamble. Or if you gamble, it's simply because you have enough money to spend for some entertainment. Okay, now step one, the best point estimate is X bar equals to 189, a critical value. We need 99%, huh? So let's sketch that to have a feeling of what's the critical number, what's the coding we put into our calculator. 99% in the middle, so the remaining 1% will be shared by two tails, that's 0.5% on each side. So the critical value here will give us area to the left, 0.5% plus 99%. That's 99.5%. That's inverse norm, 0.99501. That's usually 2.575, but I'm not sure. Give me a second. Yeah, you try to do that too, not only depending on me. 2.57583. So you see, the larger the confidence level, the bigger the size, the smaller the tail. The smaller the tail, the further this C-score go to the right. Okay, so the C-score will get larger as the confidence level increases. Then the second step, how about the margin of error? Margin of error, E, is equal to the critical value. You see, the larger the critical value, the larger the sample size. I mean, the larger the margin of error. 2.57583 times the population standard deviation is 87 divided by the square root of sample size 90. No, I'm sorry, 40. So you see, the larger the sample size, the smaller the margin of error, the larger the confidence level, the larger the margin of error. Okay, you see this number coming from confidence level, and this is the sample size, right? So confidence level increases the margin of error, but margin of error will decrease when the sample size is larger. Then when we compute that, it will give us 2.57583 times 87 divided by square root of 40. I get 35.43288. So our 99% confidence interval for mu. The average loss each passenger is at least this number. Will they still make money if this is the average? Multiplied by 20, you know, not bad, right? I mean, casino is there for business, so they expect you to lose. Okay, that's how they make money. Okay, the thing is, they actually give you a head start by giving you maybe $20 plus providing you the accommodation, like the transportation to go there. Okay, and if you win enough, they will provide you some room, hotel room, for example, so that you stay there and keep on playing for them to get the money back. If you win some money. Okay, if you lose some money, they may give you that room also just to entertain you, you know, more or less to make you lose more. Okay, but don't forget, they are there in the business of entertaining you at the same time, take your money away. So they do what they're supposed to do. Okay, don't blame them. That's what they sign up for. Okay, don't blame the manager. Oh, you know what? You're not supposed to take my money. No, that's what they do, man. That's what they were hired for. Okay, yeah. Now then, on average, they will lose 153.56712. I make it 5 decimal places here, and this will be 224.43288. Okay, that's the average with 99% confidence. Now, with this said, then suppose there are 40 people playing, just multiply that by 40. So you expect them to lose and therefore the casino win at least this much, at most this much. Can that be more than this, Thomas? Yes. Can that be less than this, Thomas? Yes. But I'm 99% sure, I may be wrong, that 1%, other than that 99% is the chance, quote unquote, the chance that I get it wrong. Okay, but I'm 99% sure that that group of 40 people will provide me some around $6,000 at least, up to around $8,800. So even if the bus costs $600 and then each person I give $100 for them to play, I still actually make money, you know. But $100, nah, I don't give them that much. I just need enough incentive to bring them to my casino and play. And when they play, after they use the money I give them, then they start using their own money too. That's how they can lose that much. Okay. Now, I'm not teaching you here to how to take people's money like that. But when you get hired, then you do this kind of computation. Okay. Now, then your boss may ask you like, well, why you make that kind of policy? You provide the bus for them, and the bus needs to go back and forth 4 times to go pick them up, send them to casino, and then send them back to their place, and then come back to the casino to rest, right? 4 times that trips. Plus, are you crazy? You give like each passenger, 40 passengers, $20, a total of at least $1,000 there. You are spending $1,000 casino money for no reason, and then you will give them this kind of argument. You will give them this kind of argument. Say, sir, on average, according to my computation, we expect them to lose on average at least $153. Well, up to $224. Okay, but with 40 people in that bus, then we will make approximately at least $6,000. Okay, and without that bus, we cannot even make that money. Okay, now trust me, your boss will love you so much for that. Okay, yeah. The reason that your boss actually hire you so that you can make money for the company, right? Now, of course, only using this kind of computation, and if it is successful, of course, then you can ask your boss, don't you think it's time for me to get some raise? Right? Now, if you don't do anything extra for the company, I mean, just think of that, you as your boss, right? What reason you give me to give you a raise? If you just do whatever I told you to do without any improvement, okay, now you suddenly bring in statistic out by Mr. Harjuno and make the casino richer, and you want some share from that money. And that's how you do it. Okay, now it's 8:59. I would like you to do one problem together with our break. Let me see this one. Give me a sec. Okay, where's that? Oh, hold on. Give me a second. I downloaded earlier. They ask you to do this problem. Okay? Okay, together with your break, we come back at 9:15. Yeah, your break is 10 minutes. We come back at 9:15. We should be done with this. When people smoke, the nicotine they absorb is converted to cotinine, which can be measured Now, a sample of 40 smokers, so N equals to 40, has a mean cotinine level of 172.5. So that's X bar. That's not mu. How do we know that's from the mean and not from the population? Because of this wording. A sample has a mean. Okay, so this is the part that I cannot really teach you though, the reading comprehension. Yeah, I need you to be able to comprehend what you read. Yeah, that's a part I cannot really help. Okay, so if you ask me how do I know it's from sample, well, because it says so there. Okay, but Thomas, I read it, but I don't get it. I don't get it. Why you don't get it? That's the best I can say. Okay, but I don't teach you English, unfortunately. Okay, now then, it says here that the sigma is known to be 119.5. So let me write it down here. Sigma equals to 119.5, and the confidence level is 90%. Confidence level is 90%. Okay, now find a 90% confidence interval in estimate of mean cotinine level of all smokers. So step 1, that will be best point estimate X bar equals to 172.5 critical value. Let's see, critical equals to inverse norm. I believe you have done your work, right? Then you will be 0.95, okay, comma 0, comma 1. Not 0.90, 0.95, because the area in the middle is 90%. The remaining 10% is being shared by two tails, so the area here will be 5%. If this were the critical value, then the area to the left of that will be 95%. That's how I get that 0.95. Okay, and then I get the critical value is 1.64485. And then the margin of error is 1.64485 times 119.5 over square root of 40. That will be 1.64485 times 119.5 over square root of 40. I get 31.078 797, so that would be 80, huh? 90% confidence interval for mu. Don't forget to do this declaration. You need to make that declaration. That will be 172.5 minus margin of error 31.0780 less than mu less than 172.5 plus 31.0780. The answer get 141.421.0. This guy here is 203.57880. Okay, now that's for this guy here. Let me go on to something new for you. in my quiz, in my test, this is how you will do it. Okay, in my quiz, in my test, this is how you will do it. And but in case you have multiple choice, so I anticipate two following situation. Your department final later on, may have multiple choice question. Now, but I also anticipate some high school students here. Among you, there are some high school students who may take AP stats, where you use TI-84 and I'm not sure though. I'm not sure if you can use TI-84, but I think you can use TI-84 now. Then and yeah, AP stats have multiple choice also. Okay, now with multiple choice, they don't care how you get the answer as long as you get the answer. So I will teach you how to use calculator to get us an answer similar to this. The difference is my answer is 5 decimal places. So in my test, you need to give me 5 decimal places and you need to show me the work though. Okay, you need to show me the work the way I showed you earlier, right? Okay, but in case you want to do checking, you want to check if you did your work correctly, or in case you want to do that kind of multiple choice question, then you can do the following. Ready? Okay, where do we find the, oh, I think I want to put, yeah, where do we find a method to compute confidence interval fast? Now, this is a confidence interval using z-score. Now, then how do you do that? You will go to stat, test, and then you scroll down to that z interval. Okay, so you stat. I'm writing on the I'm writing here. So using calculator. You'll go to stat and then test and then z interval. Press enter. Then they will ask you two different input. Okay, if you are given the data, you use data, but here the input will be stat. Okay, now then the sigma is 119.5. Sample mean is 172.5. Sample size is 40. Confidence level is 90%. 0.9. Calculate. Now, the thing is, you see here, they only do rounding up to 2 decimal places. So C interval, and then from there you will have either you have data. If they give you raw data, that's what you use. Okay, and then stats. If they give you the X bar, sigma, so on and so forth. Okay, the output I get is, give me a second, let me screenshot that. The output I get is this. Now, definitely, If you give me this result here, then I know you use calculator. Okay, then I know you use calculator because you cannot be more accurate than I do. Our calculator will give you only 5 digits, not 5 decimal places, 5 digits. When I say 5 digits, it refers to this: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's what I meant by 5 digits. Okay, while the one I have is 5 decimal places. Okay, but it's good enough for you to confirm if you get it right though. Okay, so after you're done with this, you want to check using your calculator if you don't make any mistake. That's one way to do it. Okay, that's one way to do it. Now that's for if we know, the population standard deviation. Let's go back to the template. Last week. Then what happened if we have confidence interval without sigma known? Without sigma known. Then we will basically use the same template. The best point estimate is the same. You will see that the only thing changed are the C-score once the sigma is unknown. And this rule actually applies everywhere. If we replace sigma by sample standard deviation, okay, so later on this will be S instead. Okay, so sigma becomes S, then the critical value will be T distribution, T critical, not Z anymore. So you will see all the time, every time you replace population standard deviation by sigma, then the associated critical value C-score will then becomes T distribution. Okay. Now, what is T distribution? T distribution looks like normal. T distribution, also called student distribution. There's some history behind it though. You may want to read it from the book. Okay, that T distribution looks like normal, but more flat. So let's say standard normal distribution looks like this. Let me use this. Standard normal distribution looks like this. Let's say this is standard normal distribution. Okay, now T distribution, it's not as high here. The peak is not as high, but therefore the tail is thicker because the area under the curve still has to be 1, right? So what happened is, because the peak is actually getting lower, then the tail getting thicker. The tail getting thicker. Is it okay? Now, the way we do it, the way we compute the notation for this T will be, so let's say this is let's say I need 95% confidence level, right? Okay, so the area here to the left of this will still be 97.5. Okay, but this is T critical. Okay, now the thing is, for T critical, there's something called degree of freedom. Degree of freedom denoted by df is n minus 1, sample size minus 1. Now, the notation for your t later on will be inverse t, the area to the left, comma, degree of freedom. Okay, area to the left, comma, degree of freedom. But that's basically all the change we need. That's basically all the change we need. Now, let me look back to the question, the last question we did here. The follow-up question, what aspect of this problem is not realistic? Now, and that's actually the reason our textbook get rid of the case when the sigma is known. What is not realistic is here. How can we know the population standard deviation without knowing the population mean? Okay, that's the part that is not realistic. How could we, or how could we know population standard deviation without knowing the mean? Now, you know, from the way we compute the population mean, population standard deviation, right? Okay, we always start with, I mean, the mean is the first extension, while the variance requires you to know the second extension. Let me say it again. The population mean has something to do with the first extension, while the population variance, and therefore population standard deviation, requires us to know the second extension. Now, how can you be able to do second extension without doing the first extension? That doesn't make sense. Okay? That's the part that they say is not realistic. However, a little fact from practical statistic is the following. Strangely, that sigma does not change easily. So, for example, the adult height that we know, right? The adult height, even though the adult height in America on average is different from the adult height on average in Indonesia. Like Indonesians are significantly shorter than Americans. So not only from the skin color, you can also see the difference from the height. By the way, I can say that half of Indonesians are actually black or brown. So what happens is this: if you have a black Indonesian and a black American, you can tell the difference right away, at least from their height. Black American is taller, significantly taller than black Indonesian. Okay. In general, Indonesians, regardless what's their skin color, they're short compared to American, regardless what's your skin color. I myself, in America here, may be considered having an average height, but when I go to Indonesia, okay, I may be the tallest among 200 people. That's how tall I am. Okay. Even though I was born there, because I've been here for more than 20 years, a bit more than 20 years, so I think the nutrition I get is basically American quote-unquote nutrition already, in which we get used to drink milk. Here we have more milk compared to Indonesia. Indonesia, maybe because it comes from very poor country, it is quite poor, right? So drinking milk is not part of Indonesian culture. Like for example, my mother-in-law, my father-in-law, who live with me right now, they don't drink the milk that I buy actually for them also. So what happened is that Indonesian on average, regardless their skin color, is shorter than American. But strangely, the standard deviation for the height in America and Indonesia are the same. It's 2.5. In other words, the standard deviation, even though it's the second extension, is actually is less fluctuating compared to the mean in most cases. Okay, so what I want to say is this: even though according to our textbook right now, and according to this question, knowing population standard deviation is not realistic while we don't know the population mean. In reality, we can use population standard deviation of a similar measurement, like for example, like what I said earlier, we measure the height of the population, right? Okay, the standard deviation of the population for heights, and in this case, nicotine level that becomes cotinine, may be assumed to be the same. And even if they differ, they don't differ that much different. Okay, such that the number we use here will be quite reliable. Okay, now, so even though they say this is not realistic, okay, but in reality, they are still very close. So what they call not realistic in practice is something we still can do. Now, let's go back to our question here. Now, this is the model that they consider more realistic. Okay. Now, if you have your sample, if you can get your sample mean, very likely you will be able to find your sample standard deviation too. Okay. But if you use your sample standard deviation in place of population standard deviation, then the distribution we use will change from standard normal distribution to T distribution. Okay, now keep that in mind. Keep that in mind. When do we know we use T distribution, Thomas? When we don't know population standard deviation. Okay, let's do one example. And I think I would just do problem from the book. For example, let me quote from the book directly. It's the book. Let me quote number 18 from our textbook. A simple random sample of size n is drawn from a population that is normally distributed. The underlying requirement is still central limit theorem. So either they tell you it's normally distributed such that you can use any sample size, or the sample size is at least 30 for us to be able to use this model. Okay, now from here we see that the sample mean X bar is 50, sample standard deviation is 8. Let me write it down first. Sample mean is 50, sample standard deviation is 8. Now in part A, they say construct a 98% confidence level. So confidence level is 98%. Okay, with the sample size n is 20. N is 20. So let's start the procedure. Step 1, best point estimate. X bar is 50. Critical value, because we don't have population standard deviation sigma, we use sample standard deviation sigma. So we need to use T distribution. That will be inverse T. Okay, 98%, So the area to the left, if this is 98%, the remaining 2% is being shared left and right tail. So if this is the critical, then the area to the left will be 99%. Okay, so this would be 0.99, comma, degree of freedom. Now, the degree of freedom is always one less than the sample size, that's 19. Okay, degree of freedom, let me write it down here, is always n minus 1. Then you use your calculator. Okay, you use your calculator, we use our calculator here. It will be second distribution, inverse t, number 4. The reason I require you to use TI-84 because if you use TI-83, you don't have that inverse t. If you use TI-83, you will not have that inverse t. Now, area here refers to the area to the left, just like before. That would be 0.99. And then enter degree of freedom is 19. $2.53948. That is 2.53948. Did I copy that? Okay. Now then, from there, we go on with what we did before. Okay, step 2, how about the margin of error? Margin of error will now be the critical value times standard deviation, supposed to be population standard deviation, but we replace that by sample standard deviation. That's why we use t, okay, over square root of the sample size. Compute using our calculator, 2.53948 times 8 over square root of 20. That will be 4.54276. And the rest, just like before, you need to declare 98% confidence interval for mu will be population mean 50 minus margin of error. This will be 45.4574, 54.54276. Okay, now that's for part A. With the time I have left, I will not go on with this part. You can go on yourself. Let me write it down here. Try part B and C. Part B and C yourself. Okay, I will not do that anymore here. Okay, it's the same procedure. That's what it is. Okay, that's the same procedure. In part B, part C, they change the sample size, or they change the confidence level, and they want you to see how will those changes affect the margin of error. But you will see that the smaller the sample size, the larger the margin of error. Okay, the smaller the confidence interval, then the smaller the margin of error. You will come up to that conclusion. Now, I would like to go on with another question, a typical question. actually. What happens if they don't give us, give me a second. What happens if they don't give us the sample mean and sample standard deviation? The thing is, I don't have it here. I don't have that kind of question here. Let me get this. Give me a second. Suppose they give you raw data instead. Oh, this information is actually good for me because I have a 6 months baby. Okay, so approximately 25 weeks. Okay, the following data represent the age in weeks at which babies start crawl based on the survey of 12 mothers conducted by Essential Baby. And the question is, let me see, that's from number 34, so you can actually follow from your book. The question part C, construct and interpret a 95% confidence interval. Construct a 95% confidence interval for the average age of at which babies first crawl. We don't have the sample mean. We don't have the sample standard deviation. This is all we have. So what do? We need to compute it ourselves. As this, we know that the n equals to 12. Okay, now what you need to do is find the sum of x and the sum of x squared. Okay, now using that, then you will be able to find x bar and s squared. S bar is the sum of x over n, right? And then s squared is n times the sum of x squared minus the sum of x in squared over n times n minus 1. So the sample standard deviation later on will be the square root of that s squared. Now in my test, you still need to do it this way though. Okay, in my test, you still need to do it this way. But let's assume that you will use calculator to help you. Let's assume that you will use calculator to help you. Then yes, I will use calculator. Second, share here. Now, what I need to do is to put this data into my column. I hope you remember how to get there. Second stats. Oops, no, not second stats. Just that. And then edit the first column. Okay, here I already occupied with the 3 numbers. I will just write them. So the first data is 52. The second data is 30, 44, 35, 39.6, 47, 37, 56.6, 39.8. So there are 12 data there. If I want to see what's the sum of x and sum of x bar, x squared, I go to stats, go to calculate one variable stats. Now we did this before, by the way. We did this before. I just remind you. Okay, the list is list 1, the first column. Calculate. Then I see there the sum of x is 459. Sum of x is 459. And then sum of x squared is 18657. 18657. In fact, our calculator already compute for us the x bar, which is 38.25. They also compute the population standard sample standard deviation for us. In this case is 10.00114. 10.00114. Now, in my test, you still need to do this though. Okay, but you use this calculator to confirm what you get. Okay, unless I just say use your calculator feature to find this, then you basically give me x bar equals what, s equals what, that's it. Okay, but if I say show compute without using calculator, I don't say explicitly using calculator feature, then you need to show me the word. Okay, I do it fast right now so that you can just do it yourself. Okay, this thing yourself. I just borrow from the result from calculator. Now I go on with step 1. Best point estimate is x bar equals to 38.5. Critical value t critical. It's 95%. 95% here. It means the remaining 5% is being shared by 2 tails. So if this is my critical value, the area to the left will be 97.5%. Right? So T critical will be inverse T, not inverse norm. No, no, no. It's inverse. You need to know how to differentiate that. And the difference is, do you know the sigma or not? Okay, that's what you need to remember. Okay, so if somebody asks me that question again, either tomorrow or the other day, Thomas, how do we know we use T or Z? Then I will ask you to watch this video again. Okay, because I said that many, many times. If you don't remember that, it's simply because you don't hit up my warning here. Okay, we use T distribution if we use S in place of sigma. It's supposed to be sigma. That's when we use standard normal, right? But if you replace the sigma, the population standard deviation, by sample standard deviation S, then you need to use T. Okay? Now, inverse T, parentheses, 0.975, degree of freedom 7. Okay? And use your calculator, inverse T, 0.975, degree of freedom 7. I get 2.36462. 2.36462. And then the margin of error will be 2.36462 times 10.00114 over square root of 8. Then we use our calculator for that. I get, why I get such a big one? Oh, okay, okay. I get 8.36115. Therefore, my 95% confidence interval for the average age at which babies first crawl is 38.5 minus 8.36115 less than mu less than 38.5 plus 8.36115. Okay, so this will be 30.13885 less than mu less than, what is this, 46.86115. Now forgive me if I make miscomputation here, but the technicality is all correct. Now, so I only give you one example here, or two, including the one that I have above. The one we have above, you are given the population, the sample mean and the sample standard deviation. In the last example here, you are given the raw data. Okay, you're given the raw data, and then you need to find the confidence interval. Now, how do we use calculator? Similar route. You will go to, let me show you. You will go to stat. Okay, but then from stat you go to test. Go to T interval. Test T interval. So T interval basically stands for confidence interval using T. Okay, let me press that. Okay. Now we already have built in here the data, the X bars 38.25, the sample standard deviation 10 point something, and then, oh, you know what? I make a mistake up there. I make a mistake up here. My mistake is, good thing I see that. My mistake is here. This is my mistake. This is supposed to be 12. So you correct yourself, okay? You correct yourself. Should be square root of 12. Okay, should be square root of 12. I remember the previous question, I guess n equals to 8. Supposed to be 12 there, square, okay? Now then I come back here. Is that what it looks like? Okay. Good thing I see this, oh, n equals to 12. Confidence level, 90%. Let me go enter, enter, enter. Go. Calculate. And let me put it here. That's what I get. Okay. Now, in fact, suppose you go back and instead you want to use the data. Remember, we put that in column 1. So I will change my cursor here to data. Okay, and they already give us the list. That's from list 1. Frequency only counted one time. Confidence level 90%. Yeah, it will give us the same number though. Okay, it will give us the same number. Now, let's now summarize this up. Your suggested homework from here will be number 7 to number 33. 7 to number 7 to number 33. 7 to number 33 from this 9.2. Okay, now here's the thing though. you can omit the part that asks you test for normality. Because this test of for normality, it depends too heavily on calculator, and we have an easy way to actually avoid using this test. All you need to do is actually get a more sample size. If your sample size is only 12, it's actually not reliable anyway, right? Even if it is normal. Okay, so in reality, in practice, we don't use sample size of 12. Okay, if we use sample size of 12, then we need to test normality. But just assume in your suggested homework later on, just assume that the number you get are coming from a population that is normally distributed. Okay, that's for 9.2. What I will do tomorrow is 9.1 and 9.3. However, there's one thing I need you to do. Okay, to prepare for 9.3, I need you to program your calculator, with inverse chi-square. Inverse chi-square. You will see YouTube video. You will see YouTube video for that, and I will post the link. I will post the link on our discussion board today. Okay, so tomorrow when you come to class, you are ready with this. Tomorrow when you come to class, you are ready with this. You already programmed that into your TI-84. The thing is, even TI-84 doesn't have this inverse chi-square distribution. Okay, again, I will post that link on our discussion board. I will say explicitly, this is watch this and program into your calculator. Okay, then that's for today.